Hi, I'm Jeff Wimmett, and I'm an applications engineer here at Altera. I'm here with one of Altera's key partners, TPACK.
Hi everyone, I'm Thomas Rasmussen, VP of Product Line Management at TPACK.
Increasingly, successful telecom applications, especially those in optical transport, need to meet stringent cost and power requirements, while also providing a wide range of capabilities. In this video, Thomas will demonstrate how TPACK has used our 40nm Stratix IV GX FPGA to build a 40 gigabit per second multiplexed transponder that meets cost, power, and functionality requirements.
Well, our 40 gigabit per second optical transport network mapping product, the TPO314, is the market's first such product based on a single FPGA. Since it uses an FPGA, our solution offers flexibility for future upgrades to support emerging standards or even customer-specific features that an ASSP wouldn't be able to support.
You'll also find that the TPO314 can be as power and cost-effective as an ASSP-based product. Now, just a few years ago, I think that we would all have agreed a standard product based on an FPGA would simply not be able to compete against ASIC-based designs. But the Stratix IV GX FPGA has up to 530,000 logic elements, on-chip serial interfaces, and the hard copy volume production path, which has enabled companies like TPACK to develop very competitive solutions, such as the TPO314.
Well, before we launch our demo, let's go through the basic setup.
This graphic shows the TPO314 with its OTU3 40 gigabit per second line interface to the right, and the 4 10 gigabit per second client interfaces to the left.
In this demo, I'll connect one of the 10 gigabit per second client ports to a test set and show that data and overhead run error-free. Inside the TPO314, let's configure one of the client ports to OTU2 and configure this OTU2 client to be multiplexed via OTU2 into OTU3.
Then we'll add the tester on the OTU2 10 gigabit per second port.
And finally, a loop on the OTU3 40 gigabit per second port. Voila! Now traffic can flow from the test set through the TPO314 and back to the tester.
Now here's the actual hardware with the TPACK Springbank ATCA box.
The box holds two boards. The lower one is a Springbank main module with the TPO314. This is where you will find the Stratix IV GX device.
Now let me provide a few more details about Stratix IV GX FPGAs. These devices are Altera's lowest power, highest density, high performance FPGAs. They have up to 48 transceivers running at speeds up to 8.5 gigabits per second. And as with their predecessor, the Stratix III devices, Stratix IV GX FPGAs also feature our programmable power technology. This is the capability that automatically optimizes logic, DSP, and memory blocks so you get the lowest power possible for your required performance.
And these features make these FPGAs ideal for our product. Now, going back to our demo, the other board is an optical port module. This is where you'll find the optical MSA module providing the actual 40 gigabit per second optical serial interface on fiber. The test set standing right here and is connected via this fiber to the OTU2 10 gigabit per second client port. Now the TPO314 is configured through a set of registers in the chip via the TPACK driver API, just like with an ASSP device. As I described earlier on, the TPO314 is configured to map traffic from the OTU2 10 gigabit per second port onto the OTU3 40 gigabit per second port.
So I'll plug this fiber cable into the OTU3 40 gigabit per second port to loop back, and then press the restart button here.
And as you'll see from the green box on the tester, traffic is now running from the test set through the TPO314 and back to the tester without any errors.
Now, some of you might be thinking that Thomas is trying to pull your leg and that traffic never actually leaves the tester, right? Well, when we remove the fiber loopback on the OTU3 port here, we break the traffic, and you can see the screen turns red here, showing us that we no longer have sync and we've lost the data connection between the TPO314 and the tester box.
And when Jeff connects the fiber loop again and hits the reset button, you will see traffic is flowing once again. Through this demo, you've seen how TPACK has been able to build a single FPGA 40 gigabit per second OTN multiplex transponder that is cost and power efficient as well as feature rich compared to similar solutions on the market. If you want to know more about TPACK and our OTN products, visit tpack.com/OTN or contact your Altera sales representative.
And if you'd like to know more about Stratix IV GX FPGAs, you can visit altera.com/Stratix4. I'm Jeff Wimmett.
And I'm Thomas Rasmussen. Thanks for watching.